Section 3.5, Graphing Functions Using Stretches and Compressions. Previously, adding a constant to the input or output of a function changed the position of the graph with respect to the axes, but it did not affect the shape of a graph. We now explore the effect of multiplying the inputs or outputs by some quantity. We can transform the inside, which is the input values of a function, or we can transform the outside, which is the output of values of a function, or the x's and y's. Each change has a specific effect that can be seen graphically. There is an activity on D2L that I designed on Desmos. Go ahead and explore that activity by changing the values for A, negative and positive, C when A is less than 1 and when it's bigger than 1, what happens to the graph of the function, and also explore what happens when you change the value for B from a number that is between 0 and 1, and if it's a number bigger than 1, also explore what happens to it when you apply a negative number there. When we multiply a function by a positive constant, so imagine that we have the function f of x, and then we multiply the function by we have f of x, and then we multiply the function by a number. Let's say it becomes a times f of x. Okay, that is a positive constant. So when we multiply a function by a positive constant, we get a function whose graph is stretched or compressed. So we get a function whose graph is stretched or compressed. And because we're affecting the y values here, that compression and stretch is going to be vertical. So we call it a vertical stretch or a vertical compression in relation to the original graph, of course. If the constant is greater than 1, then we get a vertical stretch, which means the original graph here is the original graph, which is the blue. And then if we multiply by 2, which happens to be positive and greater than 1, then the graph is going to stretch vertically, which is going to make it a little bit narrower, more pointier, and etc. And then if the constant is between 0 and 1, again, it's positive, but it's between 0 and 1, then you'll get a vertical compression, which is basically the graph is going to be flatter. It's going to be wider because it's just compressed down vertically. So that happens if you multiply the output of the function or the function by a number, positive number, of course. Negative number is going to be a reflection. So you can discover that through the activity. When we multiply a function's input, or in other words, the x of the function, by a positive constant, we get a function whose graph is stretched or compressed horizontally. Because the change here is happening to the x value, so we're going to say the compression or stretch is going to happen horizontally. And I think you guessed it. If the constant is between 0 and 1, we get a horizontal stretch. So a horizontal stretch is almost similar to a vertical compression. So here is the blue one is the original graph. And then if you multiply with the number, if you multiply the x value or the input of the function with the number that is between 0 and 1, positive, of course, so it's a fraction between 0 and 1, you're going to have a horizontal stretch. So here is the horizontal stretch. Again, horizontal stretch is almost equivalent to a vertical compression. It's almost the same as this compression right here. And then if you multiply the inputs with a number that is greater than 1, you're going to get a horizontal compression. So when you compress something horizontally, it's going to expand and it's going to become narrower and more pointier. So here is the compression. It happens here. And you can also experiment with that with the activity. Make sure to set h and k to 0 to see only what happens to these changes. And if you're looking at the vertical shift, please make b equals to 1 to discover what happens with the a value. And then if you are looking at the horizontal compression and the horizontal stretches, make A is equal to 1 and then play with the value with B to see what happens when B is bigger than 0, less than 1, or it is bigger than 1. Okay, I hope this illustration with the activity is going to help you see the transformation of real life and how that happens, and compare both vertical stretches and horizontal vertical stretches and compressions with horizontal compressions and stretches. They're almost the same. So a horizontal compression is almost the same as a vertical stretch. A horizontal stretch is almost the same as a vertical compression. I hope you noticed that with the activity, and if you have any questions, please let me know.